कहाँ पे तनवीर? मैं वो एक यूट्यूब लिंक भेजा वो देखो तो एक बार। चालू है कि नहीं है वो देखो, सिर्फ बाकी कुछ नहीं। हेलो। हाँ ठीक है ना, चालू हो गया। हाँ 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 चालू है, yes, thank you. हाँ, so the topic which I am going to cover is addition to carbon heteroatom multiple bond, right? हाँ, आवाज आ रही है अच्छे से? ठीक है। You know, in the periodic table, you know, these are the elements, right? Li, Be, B, C, N, O, F. Now, this is the central atom in the organic chemistry. This central atom can form multiple bond. These multiple bonds include carbon-carbon double bond, carbon-carbon triple bond. With nitrogen, it can form carbon-nitrogen double bond and carbon-nitrogen triple bond. With oxygen, it can form carbon-oxygen double bond. Okay. So our aim is to, when you have a carbon-carbon single bond, double bond or carbon-carbon triple bond, it means you need not talk about addition to heteroatom multiple bond because carbon atom is the same atom. But when you have nitrogen, oxygen as an atom bonded to the carbon by multiple bond, you refer it as carbon heteroatom multiple bond. Now, what is the beauty of this double bond? The beauty is, you know, electronegativity increases from left to right in the periodic table. If you consider nitrogen and oxygen, both of them have more electronegativity than carbon. Eventually, these bonds will be polarized, and these polarization will of this nature. Agreed? Okay. So, if I have some reagent which I commonly called as ENU, where E refers to the electrophilic part and Nu refers to the nucleophilic part, which species will come and attack onto the carbon? Nucleophile or electrophile? Nucleophile. So eventually this nucleophile will attack onto this and this bond will open up in this direction. And when such thing happen, what will happen? You will get a formation of a carbon nucleophile bond and oxygen with a negative charge. Eventually, this will be come in contact with any electrophile, and that electrophile may be H plus. And if this happens, the overall transformation is you get OH and Nu. So what has happened? You started with a carbon heteroatom multiple bond, and you end up adding two groups to the carbon heteroatom multiple bond. This is the title of the unit which we want to study. In my earlier class, I have explained what is carbonyl group, the structure of carbonyl group, and the prototropy. But for the sake of revision, we will repeat it again, and we will also understand, if we focus our as a representative case, if we consider carbon heteroatom multiple bond as this group. Okay. First thing first that we should know is we should know the structure of carbonyl group. Carbonyl group, both carbon and oxygen, they are in a state of sp2 hybridization, and as it forms, it means that the carbon oxygen sigma bond is formed by sp2 overlap. And after forming this sigma bond, each of these is left with unhybridized p orbital, which undergoes lateral overlap to form pi bond. Agreed? So up till now there is no problem as such. So this is the structure of carbon-carbon sigma bond and carbon-oxygen sigma bond and carbon-oxygen pi bond. Moving to the next. The next part, which is very very important when we are studying about the carbonyl group, is the phenomena which is called as prototropy. What it is called as? Prototropy. Proto means proton. Tropy means location. So when you change the structure of a molecule by changing the position of a hydrogen in a molecule, you call it as a prototropy. And one of the most common side of the carbonyl group is these carbonyl group. For example, if I draw a carbonyl group like this, let us understand the naming of the carbon in the compound. This carbon is referred as carbonyl carbon. This oxygen is referred as carbonyl oxygen. The carbon which is bonded to the carbonyl carbon is referred as alpha carbon. The carbon which is bonded to the alpha carbon, which is next to alpha carbon, is called as beta. You know that. In case you have an alpha hydrogen, the hydrogen attached to alpha carbon is called as alpha hydrogen. In case you have an alpha hydrogen in your molecule, now these alpha hydrogens are acidic. In my earlier lecture, I have told you that pKa of this hydrogen is roughly in the range of 18. These protons are rendered acidic. The hydrogens, alpha hydrogens in the carbonyl compound are acidic. Why they are acidic? They are acidic because, you know, when you want to study the acid-base chemistry, you should always focus on the structure of what is called as conjugate base. This is what I have told you in the earlier lecture. What will be the conjugate base when you remove this proton? The conjugate base would be of this structure. You will have a negative charge over here after removing the hydrogen. I have not shown other bonds just for the sake of simplicity. Assume that all other valencies are satisfied by hydrogen. Now this is the conjugate base and you have a lone pair, negative charge means you have a pi bond, you have a separation of one bond, means there will be resonance. And if I draw the resonating structure of this, I can draw it like this, and the resonating structure would be this, right? This is commonly called as enolate. Okay, so when you have alpha hydrogen, it can be taken away by base, and as it can taken away by base, now your carbonyl group shows two different reactivity. What are those two reactivity? If you consider this molecule, this is electrophilic in nature. What is the name of the carbon? Carbonyl. Carbonyl carbon is electrophilic in nature. But when it enolizes, when it is converted into enolate, this alpha carbon becomes nucleophilic. Now it can act as a nucleophile and can combine with any electron. Group shows two inherent reactivity. What are those two reactivity? Alpha carbon is electrophilic in nature. Sorry, carbonyl carbon is electro and alpha carbon is nucleophilic. Means if you can bring a electrophile will prefer to go on to the alpha carbon. There are other aspects of the carbonyl group chemistry. We'll deal with it one by one. But this is just basic understanding that you should have before going for the carbonyl group chemistry. Moving to the next part. This is one reactivity which I have shown. That carbonyl group you can welcome this carbonyl carbon you can have an attack of nucleophile, right? Any nucleophile can come and attack onto the carbonyl carbon by this mechanism. What are the examples of the nucleophile? Examples of the nucleophile are Cn minus, right? R minus, which you can get from organometallics like RMGX, RLI, etc. Okay, or it could be something like your enolate. Enolate is also a nucleophile. This nucleophile can attack onto this carbon. Okay, कहाँ से अटैक करेगा? Alpha carbon. Attack will be from alpha carbon. I will try to write it on the upper side of the board. Okay. So this is one part. Second part is what? Your alpha hydrogens in the carbonyl compound, they are rendered acidic, and as they are rendered acidic, what will happen? What will happen? They can be converted into enolate. Okay. So this inherent reactivity will be shown by this carbonyl compound. Now, if your carbonyl compound has got, let us understand what is referred as keto-enol tautomerism. Prototropy, keto-enol tautomerism is an example of one of the aspect of prototropy is keto-enol tautomerism. Okay, what is keto-enol tautomerism? Let us say I will write one hydrogen here just for the sake of understanding that this is alpha hydrogen. Now these alpha hydrogen can eventually go to this position NH can go over here. If this happens, what will happen? It will become OH and it will become double bond. In this you can see prominently see a carbonyl group. This form is referred as keto form and this form is referred as enol form, which is a combination of in plus ol. In for this double bond and OH refers to OL. Now, if I take this is an example of acetone. In the laboratory, you have a bottle of acetone. Now the question is, when I am writing this equilibrium, the question that should come to my mind is whether if I have a bottle of acetone in my laboratory, the acetone is in keto form or enol form. Now, whether it is in keto form or enol form, this has been determined by the value of what is called as K equilibrium. The K equilibrium, if I write it as keto upon enol, or if I write, we generally write product on the numerator and reactant as a denominator. The value of this will come out to be 10 raised to power minus 6. Means it is 1 upon 10 to the power 6. What physical significance you can draw from this? If you take 10 to the power 6 molecule of acetone, they will be in keto form and only one molecule will be in enol form. So this equilibrium, which I have written both the sides forward and backward equilibrium of same size arrow, essentially you will have this equilibrium. Your backward arrow will be very large and forward arrow will be very small, and the equilibrium constant value is 10 to the power minus 6. Now, how I can move this equilibrium in the forward direction? Remember that in keto form, this form is acidic, whereas enol form is more acidic. How come? If I want to compare, keto form is more acidic or enol form is more acidic, what I will do? I will take out the most acidic proton out of the molecule. If I take out the most acidic proton of the molecule out, I will get the corresponding conjugate base. What will be the structure of the conjugate base? The structure of the conjugate base would be this. If I take out the most acidic hydrogen out of this enol form, what will be the structure? This will be the corresponding conjugate base of the acid. Now you can apply the principle of Areo to compare whether this is stable, more or less that will be decided, or this is stable. दोनों में से जो stable रहेगा वो ज़्यादा acidic. So what was my statement? Keto form is less acidic than enol form. We'll try to justify this statement. How we can justify this? If you look at this, in this molecule there is a possibility apply Areo. Areo refers to which atom is charged on. R stands for resonance, I stands for inductive, and O stands for orbital. Means on the basis of this, which atom is charged on, कोणत्या atom पर charge आहे, is there a resonance stabilization, is there an inductive effect, or negative charge is present in which orbital, sp, sp2, sp3. So here you can find out that here the negative charge is on the carbon, whereas the negative charge is on the oxygen, and oxygen can accommodate negative charge better than carbon. So who wins? Oxygen wins over carbon. Means this is more stable and this is
very stable.
that is why we said enol form is more acidic than keto form. In other words, you can say that acidity is expressed in terms of pK. Smaller the pK, stronger is the acid. Okay. Or you can say that pKa of enol is greater than, is smaller than, right? pKa of keto form means keto form has higher pKa than enol form. Okay, so with this background of enolization, we will proceed further, and we will try to understand what are the factors that favors keto form or enol form. There are 4 to 5 different factors which decides whether keto form will be stable or enol form will be stable. याचे के 4-5 factors है that we will deal with them one by one. Now let us say if I have a carbonyl group, okay, if I have a carbonyl group of say acetaldehyde, and let us say I have one ethyl group over here. Okay, if you compare the which of them will be more in enol form, और इन अदर वर्ड हम ये सवाल का जवाब देंगे कि दोनों में से किसका इनोल स्टेबल है. इसका इनोल पहले निकाल लेते हैं. इसका इनोल क्या बनेगा? डबल बॉन्ड OH H. क्या करना है? अल्फा हाइड्रोजन लेना है, ऑक्सीजन पे डालना है, डबल बॉन्ड इधर शिफ्ट करना है. Similarly, we will do this same thing. Here we will write OH H and so the first factor which decides which form will be, which enol will be more stable is substitution. You need to focus on the carbon-carbon double bond. In carbon-carbon double bond, this side is same in both the cases. Only difference is here you got H and H, here you got CH3 and H. Now, more the substituted double bond, more stable is the alkene. This is the general rule that comes from the heat of hydrogenation of alkene. Alkene में जितना ज़्यादा double bond substitution रहेगा, उतना alkene stable. तो इन दोनों में से कौन stable रहेगा फिर? This enol will be more stable than this one. So, if you compare the equilibrium constant of these two, you will find that the equilibrium constant for this will be slightly greater than that of this. थोड़ा सा ज़्यादा रहेगा. So, is again this can be attributed to the fact that second factor जो है, अब इसके अंदर हम ये देख लेंगे एग्जांपल के तौर पे. Okay, so these are the values of, you can see in the slide what will happen if you see, if you compare what इन तीनों के इनोल कंपेयर करेंगे. इसमें CH3 है, इसमें CH2 CH3 है, और इसमें 2 CH3 दे दिए यहाँ पे. मतलब यहाँ एक कार्बन का सब्स्टिट्यूशन बढ़ाते गए. 3 हाइड्रोजन, 2 हाइड्रोजन, 1 कार्बन, 1 हाइड्रोजन, 2 कार्बन. अब इनका जब इनोल चेक किया गया तो पता चला कि ये जो पहले वाला है उसके अंदर का लेस सब्स्टिट्यूशन है, आखिरी वाले में ज्यादा सब्स्टिट्यूशन है, तो उसका इनोल ज्यादा स्टेबल रहेगा. ओके. Second factor that comes into play is referred as conjugation. Now, if I draw two different structure, again we will deal with the same aldehyde, just we will change the substitution on this side. If I make a 6-membered ring over here, okay, and on the contrary, I make a 6-membered ring on this side, okay. So, and we will make it CH3 and CH3. Now, which is the enolizable hydrogen here? In this case, there are two enolizable hydrogen because this happens to be alpha carbon, this happens to be alpha carbon. In this case, this is alpha hydrogen, alpha carbon, but there is no alpha hydrogen here. 1, 2, 3, 4, चारों valency खत्म होगी, but this happens to be the alpha carbon in this case. Agreed? So, if we try to make the enol on this side, and if we compare it, let me draw the enol of this side. You will make it double bond. Similarly, you will make it OH and you will make it double bond. Okay. Now this double bond is not having any other double bond in conjugation. But look at this double bond. This double bond, single bond, double bond. Double bond, single bond, double bond means conjugation. So this is more stable than this. So second factor is what? Conjugation. If you compare the values, the value for the enol ketoenol tautomerism for this corresponding compound without conjugation will be in the range of 10 raised to power 8. Whereas for this the value will be 2 into 10 to the power 7. 10 पट का फर्क गिर गया एक conjugation आने से. 10 raised to power 7 और 10 raised to power 8 बहुत बड़ा फर्क है. Got it? Second factor समझ में है? Now third factor is hydrogen bonding. Now sometimes what happens? Let us again deal with the same ketone. And if this ketone is again having a C double bond O here. Okay. Now you have 2 alpha hydrogens here and 3 alpha hydrogens here. Again 3 alpha hydrogens here, right? If you compare the pK of this, the pK of this will be in the range of 18, whereas for this hydrogen the pK would be 9. मतलब ये ज्यादा एसिडिक हो गया, बहुत ज्यादा एसिडिक हो गया. 10 to the power 9 times more acidic than this. Now, if you try to make an enol of it, you can take this hydrogen. You can take either on this side or on this side. What will happen? If I take it on this side, I will make it a double bond. I will make it double bond O and CH3. Now this hydrogen is very close by to the oxygen and it offers an excellent intramolecular hydrogen bonding. And this hydrogen bonding makes this molecule very, very stable. Very, very stable. Got it? So, if there is a possibility that when enol formation takes place and there is a possibility that your enol form gets stabilization because of hydrogen bonding, then the equilibrium. Now, what if I have a double bond? I have, let us say, again a double bond over here. Okay, this kind of framework is there. You can convert it into ring as well. Ring se karo mat karo usse farak nahi padta. Now, even if I make a enol of any of these two, iska bana lete hain. Double bond OH. Now, this hydrogen is far from this oxygen. Now, there cannot be hydrogen bonding. So, this enol will be less stable than the enol of this. So, hydrogen bonding plays a very important role in this. Another interesting part is you can again see that sometimes if the molecule is aromatic in nature, again take the same example. Let us say you got a carbon oxygen double bond, okay, convert it into ring, ring में बना दिया उसको. Let us say you got this hydrogen over here, and if your ring has got two double bond over here, okay. Now, if I convert it into enol, what will happen? OH goes here, okay. OH goes here, double bond here, and two double bond here. Now this ring has acquired what is referred as Huckel's aromatic sextate. Means this compound becomes aromatic. And if you see the equilibrium, this equilibrium is shifted very much towards the enol form, which we commonly called as phenol. अपनी केमिस्ट्री में उसको हम क्या बोलते हैं? फिनॉल. एंड फिनॉल के बॉटल में कभी ये स्ट्रक्चर एग्जिबिट नहीं होता. Actually, this is the keto form of phenol. This is the enol form of phenol. And phenol exists exclusively in enol form. It does not exist in keto form. Okay. So far, what I have taught you: keto-enol tautomerism, prototropy, and the four factors which affects the stability of enol. Okay. Now, there was one interesting question which was asked in one of the examination. Which of the following compound can show enolization? And the example for this is this molecule. Okay. What was the question? The question was, is this molecule capable of showing keto-enol tautomerism? As a general rule, if you go to any textbook, the textbook will tell you that if you have beta पानी पीने डोळे लागत होते. ओके, हां, पाणी पिऊन घेणे एक गुड थोडं चेंज होते मूड. नाही तुझ्या मागची वैष्णवी. हां, आता लक्ष द्या. पुस्तकांमध्ये काय सांगितलेलं असते? द बुक टेल्स यू दॅट इफ यू हॅव अल्फा हायड्रोजन देन इट कॅन शो प्रोटोट्रॉपी. इथे अल्फा हायड्रोजन आहे का? इथे अल्फा हायड्रोजन आहे का? आहे. पण तो sp2 ला अटॅच आहे. आपल्याला sp3 ला अल्फा हायड्रोजन पाहिजे. So there is no sp3 alpha hydrogen over here. इथे no, because we have two carbon. No alpha hydrogen on this side. So your obvious answer is this compound will not show keto-enol tautomerism. But this compound shows keto-enol tautomerism by engaging this alpha, beta, gamma hydrogen. If this gamma hydrogen goes over here, what happens? See the interesting phenomena. What will happen? The gamma hydrogen goes here, and while going, this double bond comes here. This pi bond, sigma bond becomes pi bond. This pi bond goes here, and this goes here. Okay. So what happens? Very interesting example. What happens? You got this cases here. Here you got OH. Here you got double bond. Here you got double bond. So this is the enol form of this compound. So sometimes whatever is written in the book is not always true. Sometimes it is a general statement, but we apply it to all the cases. So this is a very interesting example. This example in particular, which involves gamma hydrogen instead of alpha hydrogen in the prototropy. Okay. Now, why I am teaching you all these things? This is very, very important because this is the foundation that will help you to identify the nucleophile in your molecule. Because again, go back to my first molecule मध्ये 2-3 ठिकाण आहेत जिथे तो इनोलाइज होऊ शकतो, तिथे तो न्यूक्लियोफिलिक बनू शकतो. मग तो न्यूक्लियोफाइल कुठून अटॅक करेल? ते असं एक सुंदर एक्झाम्पल आहे. यू कॅन टेक द एक्झाम्पल ऑफ दिस मॉलिक्यूल. जस्ट अ सिंपल केस यू कॅन टेक. Please, you can take an example of this molecule. If I don't write this molecule is called as ester. If I don't write this molecule is called as ester. This is my alpha carbon and I have alpha hydrogen. It can enolize. But if I put one more carbonyl group over here, this is my beta carbon, and this class of compound are commonly called as beta keto ester. Now beta keto ester, obviously it has got two different hydrogens. इथे 3 आहे या कार्बोनिलच्या हिशोबाने, इथे 2 आहे या दोघांच्या हिशोबाने. Which is more acidic? Eventually this one. याचा pK 9 भरतो, याचा 18 भरेल जवळपास. So if I try to draw the possible structures of this, what are those structures? पहले इसका निकाल लेते हैं. ये वाले अल्फा हाइड्रोजन का इनोल निकालते हैं. इनोल कौन सा बनेगा? OH. एग्रीड. दूसरी बात, ये हाइड्रोजन लेके इधर निकालते हैं, मतलब OH डबल बॉन्ड C डबल बॉन्ड O. थर्ड टाइम ये हाइड्रोजन को ये कार्बन पे भेजते हैं. व्हाट विल हैपन? डबल बॉन्ड O OH OET. Okay. Now apply the factors which I have taught you. 4 factors. Substitution. This is least substituted, so this is not the stable enolate. Question का है? Identify the most stable enolate out of it. Okay. Second one is this one. This is more substituted. क्लास में होता है. हाँ. ओके. इथे पण सबस्टिट्यूशन चांगलंच आहे. हायड्रोजन बॉन्डिंग पण आहे दोघांमध्ये पण, राईट. पण याच्यामध्ये अजून एक गोष्ट खास आहे की कीटोनचा इनोल इस्टरच्या इनोल पेक्षा जास्त स्टेबल असेल. कीटोनचा इनोल, हाँ. Why? Because in case of ester enolate, you got something like 2O bonded to something. म्हणून हा इस्टरचा इनोलेट त्या कीटोनच्या इनोलेट पेक्षा कमी स्टेबल आहे. ओके. सो विच इज द मोस्ट स्टेबल इनोलेट आउट ऑफ इट? मदरला. ओके. आता याचा केव्हा काम पडेल आपल्याला? व्हेन वी स्टडी डिफरंट रिएक्शन्स. जेव्हा आपण रिएक्शन स्टडी करू ना, मग त्यावेळेस हा इनोलेट आपण बनवणारच नाही, आपण हा इनोलेट बनवूया आणि याची रिएक्शन पुढे करूया. आणि अगदी सिंपल केमिस्ट्री असते पुढची. हे जर फंडामेंटल लक्षात आले ना तर आपल्याला एकदम क्लॅरिटी येऊन जाईल. आय स्किप दिस मेकॅनिझम ऑफ कीटो इनोल टॉटोमेरिझम. कीटो आणि इनोलचा जो टॉटोमेरिझम आहे हा ऍसिड, दिस कॅन बी कॅटलाइज्ड बाय आयदर बाय ऍसिड और बाय बेस. नाउ in most of the reactions involving the carbon addition to carbon heteroatom bond, wherever you involve a enol or a keto form, you will came across what is referred as that these reactions are mostly catalyzed either by acid or by base. Why this is so? If you have something like this, okay, now in order to move this proton from this carbon to this oxygen, you need some driving force. If you compare the energies, keto form is less in energy and enol form is higher in energy. If this is an axis of energy, keto form is low in energy because of the presence of C double bond. C double bond की एनर्जी अच्छी होती है, इसके लिए वो स्टेबल होता है. C double bond C के तुलना में. In enol you have C double bond C. Key step taking place. You need to move this H plus onto this oxygen. In order to do this, what you can do, you can actually catalyze it by base or by acid. How come you can help it? For example, if you use some base will take this proton, will convert it to this, okay, and in doing so, you will get what is O minus double bond BH plus. Now this O minus will take H plus from this and you will get enol. म्हणजे या ज्याला आपण काय म्हणू साध्या सोप्या भाषेत, देर ऑकर्स अ प्रोटॉन शटल. जसं आपण बॅडमिंटनच्या शटलला इकडून तिकडे पाठवतो तसं या हायड्रोजनला इथून तिथे पाठवायचंय. Now here this base can act as a racket. How come? This base can extract the proton and can facilitate the enol conversion. Okay. Similarly, if you have acid, something like H3O plus, what will happen? This H3O plus will take a proton from this. Okay. When this takes a proton from this, it becomes OH plus. Okay. And whatever is left from the acid, any acid when loses proton is converted into its conjugate base. If I am using H3O plus, its conjugate base will be H3O plus minus H plus. कौन रहेगा? H2O. This H2O will eventually take this and you will convert. What will happen? This H2O will take this will go here, this will go here, and this H plus will be lost. And eventually, acid can also catalyze the enol formation. So, that is why you see most of the carbonyl chemistry involving the carbon-carbon bond forming reactions, they are either catalyzed by acid or by base. These are some fundamental backgrounds which are very, very essential for understanding the addition reaction. Okay. Now, this enol in particular, enol means what? This. Okay. And what is enolate? Enolate is this. Agree? This is called as enol and this is called as enolate. This hydrogen is relatively more acidic and can be taken away by base and we can get enolate. Now when you convert enol into enolate got extra stability because of the resonance. Enolate got extra stability because of the resonance. And molecular orbital picture suggests you that if you compare it, for example, instead of oxygen, if I have a carbon over here and I have a double bond, this is not enolate. What is the difference between this? This is allyl carbanion. When you have this kind of system, you call it as allyl carbanion. Okay. If you compare the stability of these two, this is relatively more stable. Okay. Moreover, if you compare the molecular orbital diagram, you will notice that in case of enolate, both HOMO and LUMO both goes down. HOMO and LUMO both goes down. Because of this, what happens? You can have the different reactivity shown by the enolate. How come? That is explained better in the next slide. For example, if this is the enolate question, right? Now, as I mentioned, if I have some electrophile with me, okay, कुठला तरी एखादा electrophile याच्या संपर्कात आणला आपण. What are the examples of the electrophile? For example, if I take CH3Br, or in other words, so what I did, I have changed the electrophile now. The electrophile coming out of it will be CH3 positive. Electrophile coming out of it will be plus minus acyl cation. Here alkyl cation, here acyl cation. When you allow this electrophile to react with enolate, what happens? In enolate, there are again two questions. This electrophile can either go to oxygen or it can attack onto the carbon. In order to attack onto the carbon, the approach would be orbital. On the contrary, in order for the attack of electrophile on this, it should be electrostatic, means based on the charges. Okay. If the electrophile that is coming, it prefers electrostatic approach, the electrophile will go to oxygen. But whenever orbital interaction means the electrophile will go to the carbon. Electrophile will go to the carbon. I will explain you with example. If you treat this enolate with CH3Br, the product obtained would be this eventually attacks onto this and this Br minus goes. And in doing so, this double bond is restored. What will be the product? C double bond O CH3. Where is the electrophile? Electrophile is attached to the not double bond alpha carbon, and the interaction is orbital. When you treat the same enolate with this, now this goes to oxygen, and what is the product? O double bond CO CH2. This is the electrophile that we have got. This is a very fundamental understanding about the enolate chemistry. That when you have some hard electrophile, something like this, where charge is very strong, you can have the electrostatic interaction winning and resulting in the formation of the bond between oxygen and electrophile. But whenever the electrophile is soft, like alkyl halide, then this goes to the alpha carbon via orbital interaction. These are the two important points that you should keep in your mind while understanding this. Okay, the details you will get in the form of presentation that I will share in your class. Okay, now this is all about, we have seen aldehyde and ketone. What are the other species that can undergo enolization? The species that can undergo enolization are, let us say, first of all, draw the carbonyl group. Put hydrogen over here, means you are talking about aldehyde. Okay. Put carbon over here, means you are talking about ketone. Put OET over here, means you are talking about ester. Put OH over here, means you are talking about acids. Now try to draw the enol of all of them. Into enol हमने निकाले, no question. Try to draw the enol of this also. What will happen? Double bond OH. Try to draw the enol of this. Right? Double bond. There cannot be two OH on the same. This enol is. That is why carboxylic acid do not form enolate. Okay. Esters do form, aldehyde do form, ketones do form, but carboxylic acid do not form enolate. Okay. So this is one important point that you should keep in your mind. Okay. Now, it is not necessary that you should have a carbonyl group always. What if you have C double bond and H? Same thing will happen. You have C triple bond and I will write it in the same fashion because we are used to writing down the structure likewise. And you have got alpha hydrogen over here. Will it undergo enolization? Yes. Okay. If I have something like NO2 group and I have this alpha hydrogen, again, yes, because NO2 group can be written like this. This eventually becomes your alpha hydrogen. Okay. So all these species will show enolization. This is the just basic understanding that you should have with you. And now we are heading towards enolate chemistry. And enolate chemistry, you should understand what is the difference between kinetic and thermodynamic enolate. Now, the factors that affects the stability of enol or enolate are substitution, conjugation, hydrogen bonding, and aromaticity. Based on these four factors, we can eventually tell which enolate will be stable. Okay. Now, let me take you to the very fundamental point, and that point is what is referred as kinetic versus thermodynamic control. Okay. Now, thermodynamic means, kinetic means which is formed because of the establishment of the equilibrium fast. क्या कारण है इसमें? And thermodynamic means which leads to the formation of stable intermediate or stable product. Okay. So thermodynamic control means you are getting something very stable. Kinetic means you are getting something which is formed very easily and very fast. This is the basic difference between kinetic and thermodynamic control. Okay. The product which is formed, again more details you can get in the slide because this is not a point of our discussion right now. Let us have an example and understand what is thermodynamic and kinetic control. Okay. Now, for this, I will take a very simple example. This example. Okay. Eventually, I have two different types of alpha hydrogens in this molecule. So, I can form two different enoles. And if I treat it with base, eventually I will get corresponding enolate. Okay. Let us form the enolate of this on utilizing this alpha hydrogen. What will be the structure of the enolate? Right? If I take this hydrogen involved in the prototropy, what will be the structure? Which enolate is more stable? Substitution. Which carbon-carbon double bond is more substituted? Four factors. मैंने अभी तक जो पढ़ा है उसमें से ऐसी एक भी चीज नहीं थी जो काम की नहीं थी. तुम्हारे को इसमें से 50% भी पकड़ में आ गया तो आगे का रास्ता सोपा है. इन दोनों में से कौन सा इनोलेट स्टेबल है? ये जवाब क्यों दे पा रहे तुम? क्योंकि मैंने आपको फैक्टर्स अफेक्टिंग इनोलेट स्टेबिलिटी पढ़ाया है इसके लिए. इसके सिवा नहीं दे पा रहे. ओके. सो ये वाला फास्ट बनेगा, ये वाला स्लो बनेगा, लेकिन ये स्टेबल रहेगा. दिस इज माय थर्मोडायनामिक इनोलेट, दिस इज माय काइनेटिक इनोलेट. ओके. अब कभी-कभी क्या होता है? कभी-कभी मुझे काइनेटिक इनोलेट चाहिए, कभी मुझे थर्मोडायनामिक इनोलेट चाहिए. फिर मुझे अगर काइनेटिक इनोलेट चाहिए तो मुझे क्या करना है? मुझे अगर थर्मोडायनामिक इनोलेट चाहिए तो मुझे क्या करना है? ये दो चीजें अपने हाथ में कंट्रोल है. किसके हाथ में? केमिस्ट के हाथ में. केमिस्ट के हाथ में कंट्रोल है मतलब क्या? केमिस्ट के पास रिएक्शन कंडीशन कंट्रोल करने की ताकत है. एक रिएक्शन है जो आप गर्म करके भी कर सकते हैं, जो आप ठंडा करके भी कर सकते हैं. तो ठंडा गर्म करना किसके हाथ में? केमिस्ट के हाथ में. अगर मुझे काइनेटिक चाहिए तो मैं लो टेम्परेचर प्रेफर करूंगा. अगर मुझे थर्मोडायनामिक चाहिए तो मैं हाई टेम्परेचर प्रेफर करूंगा. क्यों? क्योंकि ये कम स्टेबल है और ये मोर स्टेबल है. तो सेकेंडली व्हाट यू कैन डू, अगर मुझे ये हाइड्रोजन निकालना है और ये हाइड्रोजन निकालना है, तो अगर मैंने बहुत बल्कि बेस यूज किया, बल्कि एक बेस यूज किया जो बल्कि है, मैंने मैकेनिज्म बताया. बेस क्या करता है? बेस कैन आइदर टेक दिस प्रोटॉन और कैन टेक दिस प्रोटॉन. अगर मैंने एकदम ऐसा बहुत भारदस्त बेस यूज किया, बल्कि बेस यूज किया, तो बल्कि बेस क्या प्रीफर करेंगे? जहाँ पे गर्दी कम है वहां का प्रोटॉन लेना पसंद करेगा कि गर्दी में घुस के प्रोटॉन लाएगा? वो घुस ही नहीं पाएगा. तो इट विल प्रीफर दिस साइड. लेकिन अगर मैंने कहा था स्ट्रॉन्ग बेस जिसका साइज कम है, समथिंग लाइक अल्कोक्साइड, इसमें इसमें हम लोग क्या यूज करते हैं? वी यूज lithium diisopropylamide. What is lithium diisopropylamide? This compound is called as lithium amide. मेटल के जो NH2 सॉल्ट रहते हैं उसको अमाइड बोलते हैं. लिथियम अमाइड, सोडियम अमाइड, सोडा अमाइड बोलते हैं कॉमनली NaNH2 को. Now if I replace these two hydrogens by isopropyl group, कौन से ग्रुप से? कैसे रिप्लेस किया इसको? आइसोप्रोपाइल ग्रुप. It becomes lithium diisopropyl amide. ये अब इसका बल्ब बढ़ गया ना, ये बल्ब बढ़ने की वजह से ये क्या करेगा, काइनेटिक इनोलेट फॉर्म करेगा. ओके, नाउ this can be again explained very nicely why low temperature and high temperature favors this. For example, if you have your starting material over here, and if I try to draw the energy profile diagram, what will happen to the inolate? Okay, so if this is my starting material, inolate is an intermediate. Intermediate would be higher in energy as compared to reactant, no doubt about it. But if you try to perform the reaction at low temperature, then I will get the kinetic inolate. Let us say this is the energy of activation for this. इसका आगे क्या हो रहा हो मालूम नहीं हमको, हम इनोलेट तक की बात करेंगे. But if you want to prepare thermodynamic inolate, what you have to do? The energy barrier is very very high. जब हम इसको हाई टेम्परेचर पे लेके जाते हैं ना, इफ यू कैरी आउट द रिएक्शन एट लो टेम्परेचर, तो ये बैरियर तो क्रॉस ही नहीं कर सकते हो, तो थर्मोडायनामिक इनोलेट बनने का सवाल ही नहीं आता. लेकिन जब मैं लो टेम्परेचर यूज करता हूँ तो ये एनर्जी बैरियर आसानी से क्रॉस करके ये इनोलेट बन जाता है. हाई टेम्परेचर दूंगा तभी ये बनेगा. इसके लिए लो टेम्परेचर फेवर्स काइनेटिक इनोलेट, हाई टेम्परेचर फेवर्स स्टेबल इनोलेट और थर्मोडायनामिक इनोलेट. सेकेंडली, व्हाट इफ आई रेज द टेम्परेचर? आप बोलेंगे ये तो एनर्जी ऑफ एक्टिवेशन हाई टेम्परेचर पे भी अचीव होगा. एग्री, ये तो सबसे पहले बन जाएगा. जैसे मैं टेम्परेचर बढ़ाना शुरू करूंगा सबसे पहले ये बन जाएगा. लेकिन as the temperature is high, this becomes reversible. बनेगा, वापस पीछे आएगा और फिर ये ऊपर कटेगा. लेकिन यहाँ पे से एक बार ये क्रॉस करने के बाद में वापस आने के लिए उसके पास रास्ता नहीं है. It becomes one way and it becomes two way. यहाँ से वो वापस आ सकता है. So on the basis of energy profile diagram, you can explain कि kinetic inolate high temperature पे converted into thermodynamic inolate. Okay. अब इसमें क्या होता है kinetic और thermodynamic inolate में? बहुत इंटरेस्टिंग फिनोमेना जो हमको देखने को मिलती है, वो क्या देखने को मिलती है? Okay, that I will tell you. Now, remember that if I have this ketone, here I have 2 alpha hydrogen, here I have, eventually I can get 2 enolates if I treat it with base. Enolate on this side, enolate on this side. If I treat it with electrophile, and if I carry out the reaction at low temperature, if I use very strong base and high temperature, what will happen? Where will the enolate formation takes place? On this side. Okay. And chlorine. Okay. Chlorine will give me Cl positive and Cl negative, partial positive and partial negative. Eventually, the product would be this. What will be the product? Because why? Because as I have used strong base which is not bulky in nature, non-bulky strong base I have used, it will take away this proton to form the more stable enolate of this. This enolate eventually attacks onto the chlorine to form this molecule. So कार्बन क्लोरीन बॉन्ड यहाँ हुआ, यहाँ नहीं हुआ. ये कौन सा प्रोडक्ट है? थर्मोडायनामिक प्रोडक्ट. ओके, व्हाई? बिकॉज थर्मोडायनामिक इनोलेट. अब जो मैंने तुमको बताया उसके एप्लीकेशन तुमको अभी एक समझ में आएंगे यहाँ से आगे. ओके, नाउ अगेन इफ वन मोर एग्जांपल आई विल गिव यू. थोड़ा अच्छा एग्जांपल लेते हैं. ये एक कॉमन सिस्टम है जो बहुत ज्यादा स्टडी की जाती है. हमने क्या किया था, तुमको ऐसा कीटोन, ये कीटोन से शुरुआत किया था. ये कीटोन को रिंग में कन्वर्ट कर दो. नाउ दिस साइड काइनेटिक इनोलेट, दिस साइड थर्मोडायनामिक। अब अगर मैंने थर्मोडायनामिक कंडीशन दिया, कंट्रोल यूज किया, तो इलेक्ट्रोफाइल यहाँ आएगा। अगर मैंने काइनेटिक यूज किया तो इलेक्ट्रोफाइल यहाँ आएगा। What? This is a very common system for understanding this reaction. Now, if we treat it with say NaOH and CH3I, क्या होगा? हाइड्रोक्साइड, नॉन बल्कि स्ट्रॉन्ग बेस। कौन सा इनोलेट बनाएंगे? थर्मोडायनामिक। अल्किलेशन कहाँ होगा? यहाँ पे। So I will get this product. लेकिन एक केमिस्ट को टास्क दिया कि इससे भैया यही बना के दे, मेरे को ये नहीं होना, मेरे को ये होना। एक मिथाइल ग्रुप इधर से ला, मेरे को इधर नहीं चाहिए। What he will do? Kinetic control. Low temperature. We will use strong, bulky base, something like LDA, lithium diisopropylamide. अब कितना आएगा प्रोडक्ट? What is the condition? LDA minus 78 degree Celsius and CH3I. देखो रिएजेंट सेम है, बेस बदला, कंडीशन बदली। दिस इज ये एक अच्छा एग्जांपल है जिससे आपको एग्जाम में क्वेश्चन आया कि हाउ विल यू एक्सप्लेन व्हाट इज थर्मोडायनामिक एंड काइनेटिक कंट्रोल प्रोडक्ट। थर्मोडायनामिक कंट्रोल इज दिस, काइनेटिक कंट्रोल इज दिस। टेक दिस एग्जांपल, टेल देम, दो चार वाक्य लिखो, एग्जांपल लिखो, यू आर डन। ओके, बहुत इंटरेस्टिंग टॉपिक है ये। इसका एप्लीकेशन तुम्हारे को थर्ड सेम, फोर्थ सेम, सेकंड सेम हर जगह होने वाला है। दैट इज व्हाई आई एम टेलिंग यू द फंडामेंटल फैक्ट्स अबाउट दिस पर्टिकुलर टॉपिक। नाउ यू कैन सी आई हैव शेयर्ड मेनी एग्जांपल्स। LDA minus 78 and benzyl bromide. Where is the benzylation takes place? Kinetic side or thermodynamic side? Kinetic side. Second example, aldol condensation. Okay, aldol condensation carrying out at LDA minus 78. I will tell you what is aldol condensation later on. अभी तक हम वहाँ पहुँचे नहीं हैं। ये examples आप लोग maybe you can see it later on after when we complete the rest of the portion. Okay. Now this is an example where you can see the bromination, alpha bromination of ketone. If bromination takes place on this side, it is thermodynamic bromination. If it takes place on this side, it is kinetic. Okay. LDA minus 78 Br2. कहाँ गया? Kinetic. NaOH Br2. It would have taken place at this point. ओके, सो ये एक इंटरेस्टिंग एग्जांपल्स है जो आपको समझने हैं और ये इसके पॉइंट ऑफ डिफरेंसेस है। व्हाट आर द पॉइंट ऑफ डिफरेंसेस? द रेट ऑफ द फॉर्मेशन ऑफ थर्मोडायनामिक इनोलेट इज स्लोअर whereas that of kinetic is faster. Stability, more stable. Thermodynamic is more stable, kinetic is less. Or strong bases which are smaller in size and strong bulky bases like LDA, DBU, सोडियम हाइड्रेट नहीं आएगा उसमें, LiHMDS कुछ नाम है जो आपको आगे आएंगे। आप LDA में ध्यान में रखें तो इनफ है। ओके, टेम्परेचर, हाई टेम्परेचर, लो टेम्परेचर, सॉल्वेंट, प्रोटिक सॉल्वेंट फेवर्स thermodynamic इनोलेट and kinetic inolate is favored by aprotic solvent. Why? Because protic solvent will again will provide a proton. Protic मतलब जिसके पास H plus है. This H plus will be donated to the inolate, and when the proton can be given to the molecule, it can undergo rearrangement kind of reaction and it can be converted into more stable one. So protic solvent favors thermodynamic, aprotic solvent favors. So if you recall back, what was the solvent used when we use LDA? LDA is to be used in the solvent like THF, aprotic solvent. Tetrahydrofuran या anhydrous ether use कर सकते हैं. Okay. So this is all about the fundamental background. Now we will take a break for 5 minutes. 5-10 minutes break लेंगे and we will see other reactions. Okay.